draft physics video. Yeah, probably. Fake Physicer of the Week award. AskASpaceman. So this is some new video I found. Watched a couple of them. Style is always a subject, I suppose, about anybody presenting theory. And everybody has their stuff. Stuff that you can like or dislike about somebody based on their voice or their mannerisms or their presentation. So, of course, he has a style thing. He's affected by whatever it is. I don't know, kind of a girly version of Joe Rogan. But anyway, so what? The content is just mush science, physics, presented in a very patronizing and simplistic way, but it's just wrong, and there's just so many wrong statements that premise the bad folly of what conventional physics has grabbed hold of as an idea. So there's silly Heisenberg, there's silly bent space, there's silly dark matter, they're all this just silly stuff that they grab to. I guess dark matter isn't the sillier part. The silly part is the expansion part. But anyway, so yeah, just so much to work with here. So there's 3 parts. So this might take a couple of videos. Important subject, gravity, though. So it's worth it.
All right, so I want to start talking about gravity and the nature of gravity and just how gravity works, how we understand gravity. And that's going to take a while. It's going to take more than one video to explore this, because I really think it's so easy to just say the easy thing about general relativity, our modern picture of gravity, and just say, oh, matter tells space-time how to bend, and the bending of space-time tells matter how to...
Yeah, it's right. It's easy to say, and it just doesn't make any sense at all. Nothing tells something, what to do. Makes no sense on its face. Space is supposed to be the empty stuff. That's why the word was invented, sort of to describe the space, the empty space in the closet, or the empty space is supposed to be nothing, not something. And so for a couple of reasons, it's stupid.
And then that's it. And that's totally accurate. That's a pithy summary of how gravity...
Yeah, pithy. Again, so this is supposed to be science. This isn't supposed to be pithy. It's supposed to be accurate. Get to it as quickly as possible. Make it as understandable as possible. But sometimes it's a little bit complicated, and a better word might be nuanced. I mean, it's not even that it's complicated. It's that our vocabulary is so broken that you have to fix it. We have words like random and spontaneous, and they really don't work, and they're ideas that we have in our head, and you have to kind of make sure that when you're talking about something, you have to premise it with some of the better axioms of everything's a process, and when something's affecting what you call you have to understand that no, it doesn't really affect you. It usually affects one part of you first, and then another, then it moves through you, like gravity, for example, in the sense that we notice it because we hit the ground and we stop moving. And that process has to move through us. If you're sitting on your ass, it moves through your ass. If you're standing on your feet, it moves through your feet. That's where you feel it.
Works, at least in our modern understanding. But there's so much rich nuance that gets lost in that quick little summary. And so I want to take this...
How can anything get lost in an oxymoronic statement like nothing tells something what to do? I mean, that's really just fucking annoying. My local Google specialist, Sharon. Yeah, bitch. Anyway, God, they ought to just drone those people. Find them, drone them. Find them, drone them.
Video, and probably the next few videos, really, to explore all the little wrinkles of gravity, pun intended, and to see this masterpiece that Einstein himself created in the early 20th century. And I actually...
So instead of making 1 half-hour video, you make 3 10-minute videos. Oh, brilliant.
Actually want to start by following Einstein's thought process. He didn't just wake up one day and boom, there's general relativity. It took him 7 years. 7 years.
Okay, so again, that's not necessarily true either. What took 7 years was the process of trying to do mathematics that could make sense out of what he was talking about. And that's what took 7 years working with Max Planck on the math.
Of brilliant insights. And
again, it's just overstatement. I mean, it's a silly metaphor, bent space. It doesn't work in 3 dimensions, so it should have never been said, because it just doesn't work in 3 dimensions. You can't bend it in 3 dimensions at the same time. So it just ends up being converging space. And that's what it should have been described as from the very beginning. And then you just have to explain whether this convergence of space has something to do with pushing or whether it has something to do with pulling. And either way, you're going to have to come up with an explanation for how it happens. Again, Newton could have done this, but everybody would have mocked him and said, you can't do that. You can't just make up crap. You have to explain what's pushing it, or what's pulling it, or how it's pulling it. How is it attached if it's pulling? what was it pulling with? What are its arms made out of? You have to explain it, and there's no explanation. It's vacuous mush. And because everybody just said, okay, we're going to go, we have no clue. So for 300 years, you sat around scratching your asses saying, well, Newton gave us what it does, and we still can't figure out how it does it. And so you just got desperate and said, well, nobody has an answer, so let's just take any stupid answer. And you could have just randomly picked any stupid answer, and you decided that was the answer. And it's the wrong answer, of course.
And blood and sweat, working hard, and blind alleys, and like he almost gave up a few times. And there was one point where he was super, super close to having.
Yeah, where do you get this story from?
General relativity right there in his hands. He was like 2 lines away, and then he was stuck on some concept, and he couldn't get past it for another 2 years. And then finally, it cracked, and he was able to figure out what it all means, how to piece it all together. And
there's no pieces are put together here at all. Again, no energies accounted for. You have movement without any cause. There's no physical mechanism causing the movement. No accounting for the energy. Everything has to be pushed by something. We all know that. You have to build a fire to have heat. You have to do this. You have to do something. And there's no do anything in this stupid explanation.
It's a wonderful journey, and so I want to share that journey. And I think it's an excellent way to approach a full understanding of general relativity. I think following Einstein's path, because Einstein had so many brilliant insights, that we can pull from that.
So again, this idea that relativity is a subject of gravity is wrong. So it says how to understand gravity, the road to relativity. Sorry. The theory of relativity is an attempt to explain acceleration. It's not an attempt, it doesn't explain gravity.
We explore what this theory means. And I want to start in 1907. 1907 was just a couple years after Einstein had figured out special relativity and a whole bunch of other things, which are totally different episodes. And special relativity was on the scene. Everyone had kind of understood that special relativity was a big deal, even though they hadn't quite worked out all the full implications of that theory.
Right, so that's the part that took 7 years. So from 2007 to 2015 or whatever, that's the 7-year period where he had to take what was a general theory. Well, sorry. I mean, he labeled them these. Special relativity was the general theory was an idea, and he had to make it into something solid, and that took him 7 years.
Big deal, because it deals with motion. It describes how things ought to move relative to other things, and that is so fundamental.
Yeah,
that is so core that in order for
why isn't it
you
working?
to have
Stay. All right. The association with motion is what triggered a thought. And now I've lost it for some reason. Relativity, yeah. The fact that motion is relative is a fact, yes. Something's going 40 miles an hour, something's going 30 miles an hour, something's going 20 miles an hour. They have a shared component if they're going in the same direction. That's understandable. So, yeah, one's only going 10 miles an hour more than the other, and one's going 20 miles more than the other. So, yes, there's relativity with absolute velocities. So that's where this conversation goes south, in my opinion, is the idea that if you're an absolutist, that is, you believe in absolute velocity, that somehow you don't understand relativity. Of course, you understand that you're still going to have relative motions. You're just saying that all motion is not relative. You're saying that there is absolutes. You can't go faster than the speed of light. You can't build yourself relative comparisons that negate some other emotion you both have. That it's just a fact. I mean, I could be going the same, as the Earth is going the same relative motion as the Sun. It has the same velocity plus the velocity around it plus its spin. So it has these added vectors, but it doesn't change the fact that it already has the same velocity as the Sun. You don't undo what it already has because it has something in common. And this conversation is always bent by these people when they want to try to negate the past, is to try to say that the past was stupid and somehow didn't know there was relative motion. Of course, Newton knew what relative motion was. He just didn't necessarily believe that's all there was relative motion. He believed there was absolute motion, as far as I know.
A physical theory, in order for you to have a theory of physics, in any field, in any branch, it doesn't matter what you're applying that theory to, it must be compatible with special relativity, because special relativity tells us about time and space and motion and relative distances and relative times and all.
It doesn't do any of that, so that's just all propaganda. It doesn't do much at all. It does nothing almost in comparison to what Newton did. So, I mean, Newton opened the window, okay, and I don't know, Einstein cleaned it, or whatever, made bigger holes in the screen or something, I don't know. But it doesn't undo what Newton did in the first place, and he's going to imply that something that Newton did was undone by Einstein. None of that happened, or redone in some new way, or different way, or some way that matters, and that didn't happen. So obviously Newton didn't tie time to gravity, and certainly didn't tie time to velocity, and that's what Einstein did, yes, but you don't need relativity to do that. You just need a theory that velocity affects the thing that has velocity. That velocity, in a sense, will cause you to go into a cryogenic state. So the faster you're going, the slower the metabolism of your atoms. It doesn't mean the slower your metabolism, doesn't mean your heart beats slower, doesn't mean a lot of things don't have to happen slower. It just means certain functions of elemental particles, atoms, change when those atoms are obliged to move in a direction. So the more speed they have, the more it messes up the arrangement of the atoms and causes what we call time dilation, which is just the cycle of the atoms, the metabolism of the atoms. But again, that's the only valuable part of relativity, is the acknowledgement of the existence of that phenomenon, which was already, a lot of people already believed in. A lot of science fiction stories were already written about going faster than light and breaking time. So that idea already existed. So we don't even need Einstein for that, technically. He provided an explanation. The explanation, in my opinion, is nonsense, but at least he provided one.
All that good stuff. So if you want a theory, it must be compatible with special relativity. It's almost like a meta theory. It tells you how theories ought to be constructed. So once
this is just
relativity is
that rhetoric is just so wrong. It's exactly how theory shouldn't be constructed. Theory should be constructed based on evidence. There's no evidence for any of this crap. And Einstein's theory was naked, essentially, when he presented it. It had no evidence. There was no experiment he could point to, no anything he could point to. And then Eddington shows up, okay, 2 years or 3 years after the theory is presented, and with a mechanism, an attempt to find a proof. And I've already discussed the Eddington experiment, but rubbish as an experiment. Says in his own journal, I wouldn't stake my life on the results. And what does the New York Times do? It posts the headline, Einstein right. So the whole theory of relativity is said to be right, even though the evidence is about one specific piece of the theory, one axiom of the theory, one premise, and that premise isn't proven by the experiment because the experiment is so marginal, even without the failure of the even if Eddington had good data, it was a tough experiment and he had bad data. And it's never been repeated as an experiment, even though we have the technology now to do it in space, which would eliminate the whole need for an eclipse. And yet we have no data verifying that this effect exists, this twice the effect of gravity on photon effect that Einstein invented merely to defend a stupid premise he should have never stated either. That is that if you're in motion, you can't, if you're not given any connection to the outside world, there's no experiment you can do in your frame that'll tell you whether you're moving or the rest of the world is moving. When, in fact, there are experiments you can do because light is universal. Light doesn't pay any attention to your stupid frame.
You can start looking around like all the other theories out there. What works, what doesn't work, what do we have to modify, what do we have to discard? Well, there's electromagnetism, brought to us by James Clerk Maxwell in the...
Bullshit again, more nonsense. So there's magnetism. There's no electromagnetism. There's magnetism. There's electricity as a phenomenon, but it's not a force. There's photons in the various forms of at frequency. So all these things have been called something, electromagnetic spectrum or electromagnetism or some other thing, and by calling them these stupid names, you put them in a category they don't belong in, and then you never really understand them for what they are. All these things, gravity and magnetism, well, those are about the only two things there are, okay, and the photons, all move the same speed. Now that should be a clue. Okay, there's a clue that this is stuff that's related fundamentally. And just leave it at that. Leave it at that. Don't electromagnetize anything. Don't try to put them in categories. Just recognize what's the difference between them. Well, the gravity thing does that, but I can never see this force in any other way but to watch it move matter. Photons, well, yeah, we can't see them moving through space either in any way, but we can detect patterns they create. But they're obviously doing something very similar to gravity in the sense they're obviously moving electrons inside of atoms. And then what is this magnetism thing but the same kind of force? And we know that if I orient magnets certain ways, it has one kind of effect, and that this effect can also induce electricity. So there's a relationship between how current moves through a wire, and that and then you can just get in. Then it gets into more detail because then you have to start talking about how atoms are arranged. But that's all that's really happening. Magnetism and electricity are just about atoms being arranged. So those two forces can be unified by just understanding how atoms are arranged. That is, they are either pressurized, voltage, either have high voltage atom or a low voltage atom. At one end of a conductor or the other end of a conductor. And that's the same as north and south on the magnets, and the electron and the proton are charged bodies. We know that, so we can just call them the magnetic monopoles. So you can unify those two forces, and then you're just, what's the difference with photons? Well, photons are just things at a frequency, so you know that's the same kind of force, it's just that it's at a frequency. Yeah. And then gravity would be the one sitting there saying to you, well, what's gravity's unique feature? And you'd say, oh, maybe its unique feature is that it's not at a frequency, and if it is at a frequency, it's at a very short length of ray, because we know we can only detect certain amounts of light, in the sense that you have to have a certain amount to the photon, a certain length to the ray, or you're not going to see it as a photon.
1800s, and James Clerk Maxwell accidentally wrote down, without ever intending to, wrote down a theory that's compatible with special relativity. In fact, that was the genesis of Einstein's thought process that led to special relativity, and that's another episode. So
yeah. Well, why don't you just say that it's based on the same kind of Gaussian theories? So it's Gauss's theory, really. It's not Maxwell's. So both of them copied Gauss.
Electromagnetism, totally legit. Thermodynamics, some modest modifications, you can make it work. Quantum mechanics, which was being developed at the same time. Paul Adrian.
So more bullshit in a sense. I mean, quantum mechanics didn't show up until much later, 20s and 30s.
Maurice Dirac would eventually marry quantum mechanics with special relativity, and that was fine.
Yeah, no, that was retarded, and everybody pointed out how it was retarded because it's completely incomprehensible mush. But whatever, keep pretending it's brilliant.
Led to some very cool results, by the way. But then there was gravity.
The antiparticle. Very cool results. Making up antiparticles, which is just a bunch of, I mean, it's going from Winnie the Pooh to some other Rugrats. It's just mixing characters. It's like having Winnie the Pooh walk into SpongeBob's cafeteria or something. It's just stupid.
right? Newton's gravity is fundamentally incompatible.
There you go. It's just a nonsensical statement. There is nothing incompatible about the basic force laws that Newton defined, and the only thing you're saying is Newton didn't really account for the fact that the sun could be processing. So he didn't account for Mercury processing because he didn't account for the sun processing. Because the sun was so much bigger than the Earth, he just didn't account for any gravitational effect that could be processing the sun. And he didn't know that the speed of the force was limited. So he didn't know that light was slower than instantaneous. So what? A tiny, tiny difference, and hardly a catastrophic error. So this whole implication that Newton is incompatible because Newton didn't know the speed of the force, which, how much do you want from him? He was only brilliant. And the fact that he didn't create mathematics complicated enough to account for the fact that bodies can have eccentric motions. He did the math based on the fact that they have a position, and the position isn't changing.
With special relativity in a bunch of ways, and one of the big ways is that in order for Newton's gravity to work, the effects of gravity have to be felt instantaneously.
So again, that's just a lie. That's just nonsense. So nothing breaks if you account for the speed of the force. In fact, the mathematics gets better. So it improves Newton's mathematics by some percentage. Okay, say there's 100 points of inaccuracy or error in Newton's math. You get rid of 50% of them just by doing the speed of light thing. So there's nothing incompatible. Nothing breaks in Newton's thing if you add the speed of light. It only improves Newton. It doesn't make it worse. It makes it better. So that's just
that if you took away the sun,
crap.
Or you moved the sun, or you did something, the Earth would immediately have a different trajectory, which it can't propagate.
So again, thinking idiotic things, like of course Newton would say the same thing. Now if you told him, okay, there was a speed of the force, and so when you change something, like say you blow the sun up, and yes, it's going to take 8 minutes before the Earth knows the sun blew up, before the force runs out. The shadow is taking its time to cast on the Earth, and the shadow, essentially the gravitational shadow, is still there essentially for 8 minutes because the photons are on their way.
Faster than the speed of light. Special relativity tells us that, so that's out. And also,
so just more nonsense. Again, nothing. It doesn't break Newton. Newton didn't account for speed in the equations anywhere. There's no place where he put instantaneous. He didn't write it anywhere. So this is just garbage to say that this is that Newton's incompatible. Newton is just incomplete. So that's all you say. You say Newton was a little bit incomplete. That's all. It was a tiny bit incomplete. A tiny bit incomplete.
For Newton's theories to make sense, there has to be an absolute frame of reference.
Bullshit. So just more nonsense. It's not in the math. It's not in any equation that Newton wrote. So why are you saying there has to be an absolute frame of reference? It has absolutely nothing to do with, and beyond the fact that you have to identify something as being in a position, and then an hour later it's in another position, and an hour later it's in another position. You just have to identify what positions the thing's in. So again, no incompatibility here whatsoever. Newton's math does not fail.
Has to be some master clock out there, some master ruler out there that is keeping track, keeping time, keeping everything measured, and so you always...
So again, this is a setup for some notion that there isn't. So to quote Einstein's, says this is where Einstein and these people, they want to sit there and create all kinds of different kinds of, a Jekyll and Hyde Stein. Okay, this is Jekyll and Hyde Stein because they're not the same Einstein. Einstein's the one who was arguing for the clockwork universe. Let's remember that. So in spite of this theory, Einstein didn't believe in the uncaused cause. Einstein didn't believe in all this amorphous bullshit. So, and he spent his whole life basically looking for a theory that would prove there's a clock. And the whole thing is clockwork.
Have that absolute reference frame out there to compare all motion against, so you can write down Newton's.
So again, the absolute frame and relativity don't have to have anything to do with each other. You don't have to separate. You don't have to separate the two things. You can have relativity and still understand. Well, it still adds up to an absolute. So in spite of what you're doing relativistically, you still can't go faster than the speed of light. You still can't do this. If we add up all your crappy frames still have to be within the rules of being matter.
Equations. But special relativity says there is no master clock, there is no master ruler.
So again, that's not what it says, and that's certainly not what Einstein said, because again, Einstein believed in a master clock and a master ruler.
That is not a part of our universe. Everything is relative, and Newton's equations are incompatible.
So again, more nonsense. There's relative, and then there's the bigger context of what you are as a thing in the universe. So you're basically saying that Einstein didn't think things were points in space, and that he could remove everything else in the space, and that point would still be doing exactly what it was doing before. So you're saying that like the Earth, for example, I could just get rid of everything else, and what would change for the Earth? It has a velocity, it would maintain that velocity, and it would have a direction, it would maintain that direction. Nothing would change for the Earth. I mean, it wouldn't be orbiting a sun anymore, but its overall direction would still be the same overall.
With it. So it has to go. Newton has to go. What are we going to
say? More nonsense. There's nothing about Newton. Well, I said it already, but I mean, that's just such a lie. Like I said, you could argue that Newton was incomplete, and it was only incomplete by this much. It's a tiny amount, relativistically.
replace it with? That was what a bunch of people were thinking about after special relativity, Einstein included. And the surprising thing is you can make some relatively modest modifications to Newton's equations of gravity and get something that's compatible with special relativity.
So this concept again. So these tiny, yes, and again, they're not incompatibility. So again, you're to describe it as if there's something you have to take out of Newton to make it compatible. And he just pointed out, no, you just have to add to Newton to make it compatible. So that's what's the bullshit here.
It's actually not so hard, but those theories lead to some incredibly undesirable consequences, like different masses will fall under these modified theories, will fall at slightly different...
Okay, so more nonsense. There's no... You'd have to break Newton to make different masses not absorb the force proportional to their mass. Newton knew that the thing is absorbing a force proportional to its mass. The more mass it has, the more force it absorbs. That's why it moves more, because it has more force acting on it. A feather and something, a 10-ton weight, okay, will absorb more force. Newton understood that's what it's doing. He didn't think the same force is causing the two things to fall at the same rate. He knew that, no, to move the bigger body, you need to apply a bigger force. He knew that. So don't pretend he didn't know it.
Accelerations, which violate what we know from going all the way back to Galileo.
So again, he uses the word violate again. You know, this is just such dishonest rhetoric to imply it, to say it. It's just wrong.
But the effects are so small, we just haven't been able to measure it yet. That was the argument in the early 20th century. Or objects will have different fall rates, different accelerations depending on their horizontal amount of travel, which again violates...
Well, obviously, there's no statement in any of Newton's math that says that. Newton was the guy who said, look, you make it go faster and faster and faster. If I make it go fast enough, it goes all the way around the planet. He's the guy who already understood that, okay, that the rate it's falling isn't changing. But if you go fast enough, okay, you're going to go faster than the rate it's falling.
Newton, in a very, very fundamental way, it violates Galileo in a very, very fundamental way.
So none of that happens. So that's just, like I said, what am I supposed to call it? He just made that crap up. No credible scientist, I don't think, would say that. So I don't know who he's quoting here, if he's quoting somebody, or he made up the statement himself. But there's absolutely no reason to think Newton would believe that. No reason to think that it wasn't already understood that the rate that you fall in one direction, the velocity or the acceleration you have in one direction, doesn't change your acceleration in the other direction. The two are not tied to each other. They're only added into a final vector. But there's nothing that one can't undo the other. Forces can only add, and they can only add in the way like you would add a negative number, by adding a negative number. Okay, so, I mean, subtracting is basically adding negative numbers. That's what you have to do. everything is, it's that stupid word that I can never remember. Just a position, superposition. So the original idea of superposition is the forces don't blend with each other. The force has to act on the other piece of matter, and the force created by that piece of matter has to act on the other piece of matter. So the matter does the addition. The forces don't interact. The forces only interact with the matter bits, and therefore you have to do the addition of each force. Each force has to be included as itself. It can't be diluted before it affects something. It has to affect it before it can be counted.
And again, the argument was, oh, these effects are so tiny, we just haven't measured it yet. But extending Newton to be compatible with special relativity ain't that big a deal. Einstein wasn't buying it. He wasn't buying it. He thought something was up. He thought there was something deeper going on. And he was looking around for insights. So like, what is the core idea? What can I take away from Galileo, from Newton, from all the classical theories of gravity? And he hit on this concept of the equivalence principle.
Right. So, I don't think, again, this is a true description of what Einstein was seeking. Was in any way hostile to anything Newton had proposed. It was just doing what Newton hadn't been able to do, which is account for the existence of the phenomenon. So I don't think Einstein had any problem with what Newton was saying, what happens, his description of what happens, and Einstein was just doing what Newton couldn't do, which is come up with an explanation for why it's happening. And then Einstein's why answer, though, is empty as a why answer. It doesn't have any value as a how does it do it? To say bent space, it's just a useless metaphor, a useless analogy. Bent space. Again, it's three-dimensional. It's not, you can't bend something in 3 dimensions. It just doesn't make any sense to use the word bent space. It's converging space, and that's already obvious. Newton could have told you that.
This is perhaps the most fundamental principle in all of studies of gravity. And it comes about in Newton's work as this strange...
All right, so equivalency principle I've talked about before. It's just, this was a really wrong idea of Einstein's. Clearly, all acceleration comes about through the same process. A force has to act on something and it causes it to move. And so we already know that something has to hit something. A pool ball has to hit another pool ball for the other pool ball to move. It's Newton. It's basically Newton's saying what's Newton's saying. It's something doesn't do something until a force acts on it. And it doesn't stop doing it until another force acts on it. So it's this equivalency. Certainly, there's equivalency in the fact that if you're moving and you stop moving, the thing that stopped you had to have this force element to it, and all of that's always going to be equal. Whether you get hit by a pool ball or you get hit by a bunny rabbit, doesn't matter what the force is, as long as it's the equal amount of force that's going to stop you. So yes, accelerating is always the same because it's acceleration. As a function, it's just the same thing. It's just saying your pieces move. But there's a key difference between accelerating in a rocket and accelerating in gravity. Gravity is moving every single one of your atoms as little individual bits of crap. It's not even your atoms, right? I'm being wrong to say it that way. To be more precisely accurate, it's moving every electron and proton. And, of course, neutrons are electrons and protons, so it's moving those too. But gravity is acting on them directly, personally, in a sense. Where in other accelerations, you're getting pushed, okay, from your feet or your ass or your whole body. If you're laying in a space chair and the rocket's accelerating, the chair is going to push you. You're not going to be moved atom by atom. You're going to be moved based on the atom's lowest contact with the chair, or the one's going to be pushed, and they're going to push the rest of your atoms. So there is a functional physical difference. And there's no point in denying those differences. And that's what this stupid equivalency principle does. It creates kind of a whitewash, and now you lose the detail. You just wiped out the contour here, and there's an important contour in understanding forces that are between chemical forces, like one atom moves, and there's another atom because it's a solid object. So when you push one atom, you have to push all of them because you're connected. and understanding that you can't push a gas that way, though. I can't just push a gas and get all the gas molecules to move. That's not going to work. So we know there's a fundamental difference between conveying force based on the magnetic tension between the atoms and conveying a force based on putting an actual force in, like electricity or some other force, and affecting the little bits.
Strange quirk that there's really, when we talk about mass, when we talk about the mass of an object, there's really two measures of mass.
No, there isn't. So this is more nonsense. I mean, there might be in the sense that you have something called atomic weight, and then you could have something called weight, as measured by a scale or something. But it all relates to the same thing. Gravity only affects these little bits, these atomic weight bits, and so it is your mass. That's your mass. And there isn't two kinds of mass. There's only one kind of mass. You have an absolute mass. And that's all you have.
There's two things. But we're so used to them being the same, we don't think about it more, but they don't have to be the same. These two measures, one is the inertial mass.
Irrelevant. So it's just saying what's your mass's current state of velocity. Where are you going somewhere right now? And is there other stuff going with you? I mean, this table's going with me around the earth, and my mouse is, and this thing in my hand, they're all going with me. Wherever I'm going, they're going. Because they're all connected to the same forces, and the same forces are dragging them along as they are dragging me along. That doesn't mean we're going to give us all zero mass now and say we have a zero inertial mass because we're all in a frame together. It's irrelevant. It's still a fact that we have atomic weight and we have real mass, and that will show up because we'll all still have this gravity.
F equals ma, force equals mass times acceleration. That tells you the mass that goes in there is called the inertial mass. It's how much oomph it takes to move an object. If you've got a small object with small inertial mass.
Yeah, no. The amount of oomph it takes to move an object is the only mass there is. There is no other mass. So he's trying to make this argument that something called an inertial mass is somehow different than your absolute mass, and they're not. They're exactly the same thing. It's just a bullshit.
So you could just flick it, it'll go. If you have a large object with a lot of inertial mass, you have to really push it to get it going, right? Well, that's one sense of mass that we're all totally used to.
That's the only sense there is. There's only mass as it relates to the fact of how force affects it and how much force you have to apply to cause the substance to move.
There's another sense of mass, the gravitational mass, the mass that goes into the equations of gravity, of universal gravitation.
So more nonsense. It's exactly the same mass. Gravity is no different than any other force. It has to obey the same rules of force. It's no different than me shooting water at something or shooting gravity at something. It's all the same thing. How much force is in it? How much, if you reduce it to a force, how much would it take? How much energy is in the material, or how much energy is in the interaction? And that's all there is. And it's only going to be calculated based on the strength of the charge of all these little electrons and protons. Their charge is the force that moves everything.
It's almost like the gravitational charge of how much an object responds to the presence of a gravitational field. Something with a lot of gravitational mass will generate a strong gravitational field, and if it's in the presence of some other gravitating mass, it will be attracted to that mass really, really well, really easily.
So again, that's a misnomer. Then he's right back to saying something stupid like they fall at different rates. No, they fall at the same rate. The feather and the anvil.
If there's not a lot of gravitational mass, it'll just want to coast along. In order for Newton's equations to work, this is
some more nonsense. In order for Newton's equations work fine, and the only thing they miss is this little subtle problem of the force moving a little bit slowly, and the fact that you have to account for the sun's precession when you have a planet that's really close to the sun.
Weirdest thing. Inertial mass and gravitational mass have to be the exact same thing.
Yes, they are the same thing. I don't think Newton would have ever invented a different mass. So again, who invented this different mass? Who made the argument that masses are different? Who did that? I mean, this is such a straw man of Newton. Newton never argued for two different kinds of mass. So who are you arguing with? Who you arguing is saying something other than the masses have to be the same.
There's no reason why they should be. Why is it? Why is it? If you imagine an object falling from the ground, and it falls at a certain rate, a certain fixed acceleration, and then you take an object that's twice as massive. Well, it has twice as much inertial mass, which means it's twice as hard to pull down, but it also has twice as much gravitational mass, which means gravity acts on it exactly twice as well. And so these cancel out perfectly, and the acceleration is constant.
Yeah, it's only constant because, again, if you just thought of the stuff being made out of these little bits, and you said, well, how many bits is there? How many bits are there? How many bits do I have to move? So it's like, how many bowling pins do you have to knock down? The feather only has 10 pins. The anvil has 7 billion pins. Well, you know you're going to need more than one bowling ball to knock down the 7 billion pins.
This is what Galileo discovered. This is what Newton put into his equations. He didn't.
Right. So now where did you get the incompatibility from? I don't understand. So I mean, this is such a convoluted argument, and with this label that Newton's wrong on it, and here you've made it so convoluted I can't tell who you're talking about now or what you're talking about, because you brought up a premise that doesn't exist, that there's any such thing as two kinds of mass.
No. He didn't know why. The inertial mass and the gravitational mass had to be the exact same thing.
It's just some more nonsense. Again, there's no such thing as another mass. So show me where Newton thought there was two kinds of mass, because I didn't see that anywhere, and I certainly don't see it in any formula anywhere where there's mass, delta mass or something. I don't see any formula from Newton that has some mass change in it. EM or something. I don't see him making distinctions between EM and RM or something. Regular mass versus inertial mass. Real mass versus inertial mass. I don't see any of those distinctions.
Einstein didn't know either. Einstein didn't know why there was this equivalence between these two kinds of masses. They have absolutely no reason to be the same.
Yeah, they have every reason to be the same. They have every reason to recognize that if I have more little bits, they're going to absorb more of something that's going through, right? So if I'm filtering something and I put, string across to filter, well, the more strings I have, the more stuff I'm going to catch in my filter. The less strings I have, the less I'm going to catch. So that's the difference between a feather and an anvil, is they only catch as much as it hits the strings, and the strings are the only part that are catching the force. So the more strings, the more stuff you catch, the more force you feel, the more force you're affected by. It's not any more complicated than that, and the same goes true for when you're creating the force. You can't create the force unless you have the strings to do it with. The feather doesn't have enough strings to create any force because it can't block any force. I mean, if you just think of gravity and the absorption of force as being something you do because you're filtering this ether, or you're filtering bent space, or you're filtering, it doesn't matter how you think about it. Again, to rationally understand bent space, you have to think of it as a convergence. That's the only way it works in 3 dimensions. So it's a convergence of space. And obviously I would argue it's a convergence of a force, so it has nothing to do with space. And it's not even a convergence of a force, it's just what force does randomly. If you randomize a force around something coming in all directions, everything in that field will feel like everything's heading right for it. Anything that hits it is going to look like it's headed right for me right from the beginning. It was a billion light years away and it headed right for me. So all of it's going to look like rays coming right towards me. So it's always going to look like it's all converging to my center of gravity, but it's just an incidental fact of having it going everywhere. So having it go everywhere, the force, equally, means no matter where I go in space, it's always going to look like it's heading right for me. I mean, that is not a intellectually challenging concept to understand.
So he took it one step further and just said, I'm going to make it be equal. I'm just going to declare it to be equal. I'm going to elevate it to the level of a principle and just say, you know what, these two measures of mass are going to be the exact same thing.
Okay, so, but he's really not talking about two measures of mass. He's talking about the phenomenon of acceleration and saying all accelerations are the same. Again, back to my argument that how force affects things. And it's just not the same. Some force hits you, okay? I mean, I throw this into my hand. This effect, okay, is going to happen in a much more complex way than just force hitting it. It's not going to be the same as gravity hitting it when I throw matter into this other hand, because the matter is going to affect the surface atoms dramatically, and it has to be transmitted through the rest. Where gravity doesn't care about your surface. Gravity is seeing the little bits inside of you. And the only connection there is that obviously if you have a whole bunch of bits, well, the gravity is going to hit the ones, others will be shadowed. So gravity will be taking place between those little bits, and those little bits end up being shielded from the force, and they'll end up being attracted and blah, blah, blah. But it's basically going to be a chemical reaction, a chemical in the sense that it's going to be atoms on atoms on atoms on atoms, which is basically electrons on electrons. So it's going to be the pressure between the electrons that are going to force all these other atoms to move because the force hit it. And that's a very different way to transfer motion or momentum. Transferring momentum by directly having a force like gravity hit you, and transferring momentum by having material substance that's in motion hit you are two different ways of being accelerated, and the process is in fact different. And by Einstein saying they're the same thing, that led Einstein to say, well, now I have to account for that equivalence, and now I have to make photons do something stupid. I have to make them bend in gravity, because that's the only way I can make them look the same in a spaceship, so to speak. That's the only way I can make a light clock in a spaceship look the same as the light clock on Earth, is I'm going to have to force photons to be bent. And I'm going to have to force them to be bent twice as much as everything else in the universe, which is taking it one step even more stupid. Whoops. We were back here somewhere.
Mass and the gravitational mass had to be the exact same thing. Einstein didn't know either. Einstein didn't know why there was this equivalence between these two kinds of masses. They have absolutely no reason to be the same. So he took it one step further and just said, I'm going to make it be equal. I'm just going to declare it to be equal. I'm going to elevate it to the level of a principle and just say, you know what, these two measures of mass are going to be the exact same thing, and I'm not going to try to explain it. I'm not going to try to understand it. I'm not going to try to sweep it under the rug. I'm just going to declare it to be true. I'm going to make a fundamental assumption about the universe.
Right, and that's all it was, is an assumption based on, I would argue, an incomplete examination of the consequence. And the consequence, in my opinion, is just to deny a fact, that photons are immune to this force, that photons don't accelerate, photons don't get bent, photons don't do any of this stuff, because they're not matter. They're force, and force doesn't affect force, as we already know from the superposition principle of gravity. The forces of gravity do not interact with each other. The gravity has to interact with the matter, and it has to go all the way. It can't feel the gravity from the other thing and the two gravities cancel each other out. That can't happen because the forces don't interact. Force does not interact with force. That's the fundamental principle. That's the one Einstein destroyed, the real principle, when he declared this, when he made this wrong assumption, this presumption, when he was presumptive, when he jumped the evidence and leaped a step he didn't need to take, and it was a step that broke a fundamental principle.
That inertial mass and gravitational mass are identical, and then we'll go from there. We'll take that as a bedrock cornerstone principle. And
how do you take something as a cornerstone principle that's based on gibberish? Inertial mass versus real mass. There is no such thing. There's no difference. There's only one mass. It's how many subatomic particles you have, and that's it. That's the only mass you have. This idiotic notion that you have some other kind of mass, like I'm moving 50 miles an hour and I put a scale in front of me, and it's moving 50 miles an hour in the same direction as I am. Oh, I don't weigh anything on that scale, right? I could jump out of an airplane with a scale, right? And the scale's sitting here right beside me. I put my hand on it. Hey, I don't weigh anything. Yeah, it's no surprise. I could put the scale right now sideways to me and put my hand on it. I don't weigh anything that way. Yeah, because gravity is equal that way. I'm getting affected by just as much this way as I am that way, so there's no difference. But I'm just saying that you're not measuring your atomic structure then, because you're in perfect balance. The only way you can see how many atoms you have is to put you in an imbalanced field. Then you can see what the filter's doing. If I'm shoving just as much stuff this way as I am that way, the filter can't tell you anything. The filter can only show you how much filter there is when there's an imbalance. All right. So we'll move on to the next one. Yeah, we'll do them in 3 parts. What the hell? And that'll be good enough, I would argue. Yeah. So till the next time and such.